So you are now ready for 2 ALEKS problems out of homework number 2. First one I'm going to look at with you is this problem, deriving KB from KA. And this is like the content in section 16.8. So in this one, you have a table, and it gives you, on the left-hand side of the table, it's giving you information for an acid, and on the right-hand side of the table, it's giving you information for a base, and some information is missing, and it's asking you to fill out the information that's missing. So let's first look at the easy part of this. The easy part is Ka and Kb and that relationship. So sometimes you're given a Ka and it asks you to solve for the Kb. Sometimes you're given the Kb and it asks you to solve for the Ka. No matter what, the relationship you're going to use there is Ka times Kb equals Kw. So if you know, like looking at the first one, if you know Ka, you're solving for Kb. Kb is Kw divided by Ka. Kw is always 1 times 10 to the minus 14. And for our first problem, the Ka is 4.9 times 10 to the minus 10. And so we just plug that into our calculator, and I am getting Kb equals 2.0, it wants 2 sig figs, times 10 to the minus 5. And that's all you have to do for that. For the other part of this problem, the other thing that's happening here is that it's giving you the formula of either the acid and asking you to come up with the formula of the conjugate base, or the other way around. It gives you the formula of the base and asks you to come up with the formula for the acid. So as a rule, the difference between the conjugate acid and the conjugate base is just the H plus ion. So the acid versus the base, the acid is going to have 1 more H plus than the base. 1 more hydrogen and also 1 more positive charge. So if your acid is HCN, your base has to have 1 less hydrogen, Cn, and it also has to be decreased by a charge of +1, going from 0 to -1 in this case. If your acid is HCH3CO2, the base has 1 less hydrogen. So let's go CH3CO2. And we've also taken away a positive charge. So we go from 0 to -1. If our base is CH3NH2, that base has 1 fewer hydrogen than the acid. So that means the acid has to have an extra hydrogen, CH3NH3, and it has to have an extra positive charge. So again, the acid always has 1 more positive charge than the base.